students, myself Dr. Divya, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will discuss the definitions and terminology for the green chemistry and fuels. So here we will be discussing different definitions and terminology that will be used. So first one is, what is green chemistry? So the title itself indicates that chemistry involves the green processes. So green chemistry is the design of chemical products and processes that reduce or eliminate the use and generation of hazardous substances. So that will reduce or avoid generation of harmful substances. Hazardous is nothing but harmful substances or the byproducts or the processes that involves harmful or toxic substances. So green chemistry is the design of chemical products and processes. So we will be using a process that is good to the environment, that we don't use any toxic substances, and also reduce or eliminate the production of any byproducts that are harmful to environment. Then what is the principle of green chemistry? So chemical products should be designed to achieve their desired function while being as non-toxic as possible. Safer solvents and auxiliaries are some of the examples. I like it is that it has to be designed in such a way, the processes and the products has to be produced in such a way that they are non-toxic as possible. Like they should be avoided. The toxicity has to be avoided. So that is the main goal and principle for this green chemistry. Next, what are green solvents? So the name itself indicates green solvents are the safer solvents that we will be using so that there are no harmful byproducts coming out from these green solvents after the processes or during the processes or the chemical reactions. So green solvents are eco-friendly, environmentally friendly solvents or biosolvents which are derived from the processing of agricultural crops. See, for example, we are using some of the solvents, so we will be using like ethanol. We can even use the bio-based, like from the biological origin, ethanol that is derived from biological origin. So that will include the green solvents that will produce no harmful substances. Then write about green solvent. So water is one best example. Water is a best example where we will be using as a solvent for many of the chemical reactions. So that can be considered as a potentially green solvent since it is non-toxic to health and environment. It is, therefore, as we are drinking daily, it indicates like water is non-toxic in nature to the health and also to the environment that are coming out after the process. Like after the process, if the water is going to the drainage system or any of the environment surroundings, it is non-toxic, so therefore it has no effect on the environment. Next, what are green synthesis? So synthesis, like processes are the in the manufacturing, we will be using these processes in form of synthesis, so that will be producing a lot of products. So the green synthesis is nothing but that doesn't produce any harmful substances or byproducts. So green synthesis are required to avoid production of unwanted or harmful byproducts through the build-up of reliable, sustainable and eco-friendly synthesis procedures. It means we are building a procedure that is nothing but the green procedure or the green chemistry. Through green chemistry, we are producing a product that is not harmful to the environment. So the process is nothing but the green synthesis. Next, define Novenangle reactions. So the condensation of carbonyl compounds. So for example, this condensation reaction undergoes between the carbonyl compounds with active methylene compounds in the presence of weak base like ammonia, amine, pyridine is known as Novenangle reaction. So this is the natural process that will generally take place. So under the catalyst and the solvent is used. So we have even green synthesis for that, and this is the condensation reaction that undergoes between the carbonyl group compounds with the active methylene compounds in the presence of weak base like ammonia, pyridine or amines. Next, define microwaves. So microwaves are like one of the part from the electromagnetic spectrum. So microwaves have wavelength range from 1 centimeter to 1 meter in the electromagnetic spectrum and are located between infrared and radar frequencies or radio frequencies. So if we see, these radio frequencies are nothing but that come out of from the satellites, like we are hearing daily from the televisions or the radios. So these are not harmful in nature, and also the infrared rays, so it lies between the infrared and the radio. So this is the microwaves that are lying between the infrared and radio frequencies. Then what is the function of phase transfer catalyst? So this is one of the catalysts that we'll be using in green chemistry. So wherein two immiscible solvents can be used, and there is a transfer of this substance from one phase to another phase. So phase transfer catalyst can facilitate the migration of reactants that are immiscible in general from one phase to another phase where reaction takes place. For example, if this is phase 1 and this is phase 2, if this is water and this is organic solvent, generally a reactant is not soluble in both of them. So in that case, the phase transfer catalyst will help in transferring from the phase 1 to phase 2 where the reaction occurs. So this is how it will help in the reaction taking place. So phase transfer catalyst can facilitate the migration of the reactants from one phase to another phase where the reaction occurs. Next, define ultrasound waves. So sound waves having high frequencies are known as ultrasound waves, like about 20 to 100 kilohertz. So this is these waves that are lying between these frequencies are called as sound waves, which have very high frequencies. What is a fuel? A fuel is any combustible substance containing carbon as a major constituent, which is capable of releasing large amount of heat. It means, for example, coal, solid, petrol, liquid, LPG, gas. These three are something like examples for fuels. So they have the capability of releasing large amount of heat or energy. So or energy. So energy in the form of anything. So coal, petrol and LPG are some of the fuels that we'll be using in our daily life. So it is a combustible substance containing carbon as a major constituent, which is capable of releasing large amount of heat. Then what is the natural fuel? So natural fuels which are occurring in the nature. So fuels which are found in nature are called as natural fuel. Examples are fossil fuels. Fossil fuels are formed from the debris of decaying matter or the organic matter after many years. Then how many types of fuels are there and what are they? So there are three types of fuels. They are solid fuels, liquid fuels and gaseous fuels. Three forms of matter and three forms of fuels. So solid fuels, liquid fuels and gaseous fuel. Define coal. So coal is like natural fuel that is occurring in the earth. So coal is a fossil fuel which occurs in the layers of earth crust. If you see this is the decaying matter. Decaying organic matter. So upon pressure and heat, it converts itself into coal with the various forms of coal. So that is lignite, bituminous, subbituminous, bituminous, anthracite. So this is the highest form of coal that is forming in the earth's crust. Then what are the different varieties of coal formed inside the earth? So if we, as I have told here, like during the formation of coal, there are several forms of coal that is forming. So first form is the decaying matter that converts into soft matter, this soft coal, that is the peat, then brown coal like lignite coal, metallurgical coal, anthracite coal and bituminous coal. So this is like coming from like this. Okay, peat, lignite coal, metallurgical coal, bituminous and anthracite. This has the highest percent of carbon. Okay, anthracite has the highest percent of carbon. Next, what are the units of calorific value? So calorie, it is like given in the form of calorie, kilocalorie, British thermal unit, centigrade heat unit. So these are the different units that we'll be using for expressing the calorific value of any fuel. What is meant by gross calorific value? So there are two types of calorific value, gross or net calorific value. So let us understand what is gross calorific value. It is a total heat, quantity of heat liberated when 1 unit of fuel has been burnt completely and the products of combustion has been cooled to room temperature is called as gross calorific value. That is the total heat that is liberated. That is the total heat that is liberated when 1 unit of fuel is combusted completely and cooled down to room temperature is known as gross calorific value. So this is the combustion that occurs, combustion in the presence of air and like containing oxygen and nitrogen. So this is the heat that is producing having carbon dioxide, water vapor and nitrogen. Then what is the temperature for determination of volatile matter? So there are several tests that we conduct for any fuel immediately after coming from the crude sample like raw or the crude oil. So like proximate and ultimate analysis, in that we have volatile matter analysis or the test. So volatile matter will determine the loss in mass less than due to moisture when sample is heated at 900 degrees centigrade for a period of 7 minutes. Why are we doing at high temperatures? Because to remove the organic matter that is in the form of volatile matter. So volatile matter is determined as a loss in mass less than that due to moisture. So that could be present even in the form of moisture when the sample is heated at 900 degrees centigrade for a duration or period of 7 minutes. So we are using 900 degrees centigrade for 7 minutes. So that will give the volatile matter content. Then what is ash in proximate analysis? Ash is nothing but the burning. So we are ashing the sample. So ash is one of the biological matters consisting mainly of salty inorganic constituents. Any salty inorganic constituents or biological matter present in the fuel will be converted into ash. So that is nothing but that we can determine during ash test. Then what is fixed carbon in coal? Fixed carbon is the actual carbon that is present in the coal. So fixed carbon is the measure of amount of non-volatile carbon. Because in the volatile matter, we are removing all the type of volatile matter that includes even the volatile carbon. So the amount of non-volatile carbon itself indicates the fixed carbon present in that particular coal sample. So what coal has the highest ash content? So anthracite is the highest ranked coal with the carbon percentage of about 87%. So we have like after a peat formation, it goes to lignite, then bituminous, and next to anthracite. So this is the highest form. This is the highest form of coal that contains highest percentage of carbon. What is moisture content? Moisture content is mass lost from a sample under specified conditions after heating coal in oven at 104 to 110 degrees centigrade. So normal heating we do for this sample like coal or any other fuel. So that will give the moisture content. So as we know, the boiling point of water is like 100. So whatever moisture present is in the form of water vapor. So that goes off at this temperature. Therefore, we are using this temperature for moisture content. Next, what is petroleum? Petroleum is a naturally occurring liquid found beneath the Earth's surface that can be refined into fuel. So petroleum is as such present as a crude oil that is present in the crude oil after we mine it from the fossil fuels. So after proper refining using the fractional distillation technique, we get very large amounts of other products also along with the petroleum that is useful for our daily life, like petrol in the automobiles and also petroleum gas. What is refining of crude oil? Refining breaks crude oil down into various components depending on the mass and other factors, so which are then selectively configured into new products. So if you see this, depending on the temperatures of that particular products, they are separated into different products. So the crude oil after proper refining will separate into different compounds like bitumen, lubricating oil, fuel oil, diesel, naphthalene, gasoline, and petroleum gas. So paraffinols. So these are the different products that we generally get out of this refining technique. What is colloidal process? So in this process, separation of colloidal water droplets from crude oil is done by applying high voltage at 2 electrodes. So we are applying 2 electrodes. So the oil that is present, any colloidal particles that are present will be separated. So this process is nothing but colloidal process. What is LPG? LPG is liquid petroleum gas. Liquid petroleum gas. So it is a mixture of flammable hydrocarbon gases that includes propane, butane, isobutane, and mixtures of 3 LPG gases. So this is nothing but that we use daily in our domestic life for cooking. So LPG is mixture of flammable hydrocarbon gases that include propane, butane, isobutane, and mixtures of all the three of these gases. Then what is CNG? Compressed natural gas. Compressed natural gas. So how is it made? We are compressing the natural gas to less than 1% of its volume at standard atmospheric pressure. So that is how CNG is made and used for many of the automobile applications. What are the applications of LPG? LPG is commonly used as a fuel for gas, barbecue grills, and gas cooktops and ovens, for gas fireplaces and other portable heaters. So LPG has a lot of applications due to its portability and also cost. So it is used for the barbecue grills, gas cooktops, ovens, and fireplaces like gas fireplaces and portable heaters that are used. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.